Okay, last example. So for this quadrilateral, I tell you that AC, this whole diagonal right here, is 8x plus 3. BD, this whole diagonal right here, is 10x minus 9, and I need you to find EC, this length right here. So again, the very first thing you always do, always, first and foremost, is identify which specific quadrilateral you're working with. Based on these markings, the only thing you know for sure is that you have 4 right angles. So right away you should be thinking, oh, it's a rectangle. You don't know if all the sides are congruent, so you can't say it's a square. You only know for sure that it's a rectangle. Now, what you know about the diagonals of a rectangle is that they're equal to each other. That's one of the properties listed in that diagram. So the given information revolves around the diagonals, and you know the diagonals are equal to each other, so there's your algebra, set them equal. Oops. Sorry guys, my pen is not working. So if I take these two diagonals and set them equal, 8x plus 3 is equal to 10x minus 9. Again, I'm not going to solve the whole equation out for you because I know you guys can do that. I end up with 2x equals 12. And if I divide both sides by 2, you get x equals 6. However, that is not the final answer. I'm asking you to tell me what the length of EC is. Now, because every single rectangle is also a parallelogram, you know that the diagonals bisect each other. So AE and EC are the same length. So what we're going to have to do is take x equals 6 and plug it back in to AC equals 8x plus 3. We have to figure out what the length of AC is. So if I plug 6 back in, I get 8 times 6 plus 3. 8 times 6 is 48. Plus 3 is 51. So that's the length of AC, the whole entire diagonal, but I only want EC. Since the diagonals bisect each other, that means EC is only half of the diagonal AC. So we have to take 51 and divide it by 2, and you end up with 25.5. So the length of EC, your final answer, is 25.5 units. There's your final answer.